Hello there, folks. It's me, Bhoomika, again. As you already know, we are through with our in depth discussion over some of the questions of the JEE main paper, which was conducted on the 25th of February in the second shift. Today, we are going to resume our discussion over the remaining questions of the same paper. Alright, so without any further delay, let's get started. Coming up next before you is this question from limits, which is extremely intriguing. Let's together check it out. So in here you are given an expression whose limiting value as x approaches to 0 is existing as a finite quantity, and explicitly its value is given as small b. So small e is occurring into the expression and small b is occurring into the limit. You have to individually fetch the values of both a and b, then plug it in here and compute a minus 2b to be your final answer. Got the drill? Now, the very first thing which pops up whenever you witness any limiting expression like these is that plug in x equals 0 everywhere. Isn't it? But when you do that here, when you perform this step here, what you end up getting is an indeterminate form 0 by 0 as the answer. So obvious strategy is to apply the L'Hopital rule. That means differentiate the numerator and the denominator individually and then proceed ahead. This is something that yes, you can do here, but I am not going to opt for this methodology to tackle this question because something smarter is tickling my head right now. Let me share that with you. What I'm going to do is I am going to focus all my attention onto this portion, which is e to the power 4x minus 1. I want you to quickly jog your memories back to the result, which said that e to the power question mark minus 1 upon question mark, this expression's limiting value as question mark approaches to 0 is 1. Basically, wherever I have kept question mark, at each of those places, whatever is sitting should be identical. Now, this result I want to use here, so I am going to divide this by 4x and to balance it out, multiply also by 4x. So in the next step, what will this give me? You know, limit of the quotient is quotient of individual limits. Using that law, I will write this as limit x tends to 0 of the numerator upon limit x tends to 0 of the denominator. Alright, so now recall that limit of the product is also product of individual limits. So denominator comes out to be limit of this expression into limit of this expression into limit of this expression. But I just shared with you e to the power 4x minus 1 upon 4x as 4x tends to 0 is 1. In here, if x is approaching to 0, obviously 4x will also approach to 0. So that means if I talk about just this expression, its limiting value as x approaching to 0 is 1. So further, this complete thing boils down to what? Something even simpler. Numerator becomes ax plus 1 minus e to the power 4x and denominator becomes ax into 4x. That's it. This complete term has converted to 1 because its limit is basically 1. Yes. So denominator becomes 4ax squared. What next? Okay, what next? Obviously, I am going to now catch hold of this exponential term and deliberately expand it using my exponential expansion. So do you remember? E to the power x is given by 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus x to the power 4 by 4 factorial plus and so on. The takeaway is whatever is sitting in the power of x, that exact same thing is going to sit everywhere here in each of the terms. So right now the power of e is 4x. So when you expand it, what do you get as the terms in its expansion? Let's see. This will be limit x tends to 0 ax plus 1 minus 1 plus power square by 2 factorial plus power cube by 3 factorial plus power to the power 4 by 4 factorial plus and so on. Yes, and denominator is the same 4ax square. Alright, Let's simplify the numerator a bit. This is ax plus 1. This is minus 1 minus 4x minus this quantity minus this quantity minus this quantity and so on and so forth. Okay, so plus 1 minus 1 cancels out. Ax minus 4x becomes what? A minus 4 into x. Alright, and I can actually distribute my denominator below each of the terms. This upon 4ax square, this upon 4ax square, this upon 4ax square, this upon 4ax square and so on. Okay. Now you know, limit of the sum is sum of individual limits. Limit of difference is difference of individual limits. So in the next step, this gives me limit x tends to 0, a minus 4x upon 4ax square minus limit x tends to 0, 4x whole square by 2 factorial upon 4ax square minus limit x tends to 0, 4x cube by 3 factorial upon 4ax square and so on. Recall that this complete limit is already given to you to be equal to b, which is a finite quantity, isn't it? That was already provided to us in the question. But at this point of time, I want you to very closely observe this term. This is a problematic term. Why? Because it has x in the numerator, x square in the denominator. X is approaching to 0, it's close to 0, but it is not equal to 0. That means I can cancel one x out from both numerator and denominator. What I will be left with is this. So numerator becomes free of x and denominator has 1x. So understand, if x is approaching to 0, 1 by x will approach to infinity. Yes, and infinity plus or minus anything can never be finite. So this is a contradiction, right? That means this complete expression should be free from this term. If somehow I can delete this term, eradicate this term from this complete expression, my limit is possible to be equal to a finite quantity. So how to get rid of this term? It's very simple. I don't want a minus 4 upon 4ax to exist as a term. So basically I cannot disturb x. So let's catch hold of all the terms apart from x. I want a minus 4 upon 4a actually becomes 0. That's what I want. Yes. Now, numerator upon denominator can be 0 when denominator is non-zero and numerator is 0. What does this give you? A equals 4. That means we have got the value of a to be 4. One task has been accomplished. If a is 4, then this complete term will not be sitting here. It will no more be sitting here and hence the problem will be eradicated. My limit will not be affected to be a finite quantity. Alright, so a is 4. If a is 4, what next? What further? What about the remaining terms? Let's check if any other term is creating any problem. This is cool. What about this term? It has x cube upon x square. The next term will have x to the power 4 upon x square. The next term will have x to the power 5 upon x square and so on. Basically, there are positive powers of x which will be sitting in the numerator. And x is approaching to 0, so each of those terms will approach to 0. Their limit will be 1. 0. Okay, so that means this will have limit 0. Further, all the terms will have limit 0. Fine. So what are you finally left with? Minus limit x tends to 0. 4x square upon 2 factorial, that means 16x square upon 2, which gives you 8x square upon 4ax square, minus 0, minus 0, minus 0, that means nothing basically. So this is what is the limit b. So did you realize what happened? The first term was giving us positive power of x in the denominator, which was problematic because that term was giving the limiting value as infinity. But my final answer was a finite quantity. So I made that term vanish, and to do that, I had to keep all the terms independent of x as 0. Then only it will get vanished, right? And that gave me the value of a as 4. Then I moved on to the next term which had x square in the numerator, x square in the denominator. Not a problem. Then I moved on to the next term, and then the next, and then the next. Basically, then all the terms had positive powers of x in the numerator. So x is approaching to 0, so all those terms approach to 0. Not a problem. So what I'm left with, just that single term which has x square in the numerator and x square in the denominator. So x square cancels out. What are you left with? 8 upon 4a. 8 upon 4a. A is 4. Yes, the 4a will be 16. 8 upon 16 gives you half. Limit of a constant quantity is equal to that constant quantity only. Yes, and minus of limit of something is limit of minus of that thing. So minus of limit of half is limit of minus half. And limit of minus half is nothing but minus half only. That means B is coming out to be minus half. Got it? I hope the drill was extremely clear to you. Yes, so A is 4, B is minus half. Plug it in this expression, what do you get? 4 minus 2 times minus half, which gives you 4 plus 1, that is simply 5. So yes, if naturally applying the L'Hopital rule strikes you, then yes, go ahead with that. But the only problem there is that when you apply it for the first time, differentiate numerator and denominator individually, then also in that step, you are going to get 0 by 0 form. In order to obtain that, your A will come out to be 4 in that step. But because you are getting 0 by 0 form again, you will have to again apply the L'Hopital rule, and then you will reach to the value of B as minus half. So that process is, yes, possible, but a bit lengthy. Whereas on the other hand, this one I found to be pretty smart and also time saving. Okay, so keep a note of this. Final answer of this question is coming out to be 5. Let us now witness this question from coordinate geometry based upon the concept of common tangent. Now, this is a concept from where the chances of questions being asked in your paper are always humongously high. It's a supremely important concept from examination perspective. The question here says that there is a line which is a tangent to this circle with respect to the point of tangency being A, B, let's call it capital P. The same line is also acting as a tangent to this parabola with the point of tangency being C, D, let's call it Q. Mind it, both these point of tangencies are distinct from one another, so they are representing two distinct points in the plane, and both these points are sitting compulsorily in the first quadrant. You are supposed to find the value of twice of A plus C, wherein you have to realize that A is nothing but the x coordinate of P and C is nothing but the x coordinate of Q. So all in all, we are trying to reach to this drill that we have to somehow compute the explicit coordinates of P and Q, so that from there we can extract out their x coordinates, that is A and C, and hence compute twice of A plus C. Isn't it? Let's start. First of all, I'll begin by visualizing the figures involved here. So first of all, I have the circle whose equation resembles x minus h whole square plus y minus k whole square equals r square, which is the equation of a circle whose center is h comma k. When you compare, you get the center to be 3 comma 0, and radius is r, which when you compare, you get 3 units. Okay, so this is how the circle is going to look like, having center as 3 comma 0 and radius as 3 units. This is my first curve. Next curve is parabola, whose equation is straight away comparable with y square equals 4ax. When you equate 4a with 4, you get a equals 1. Alright, fine then. This is the standard rightward opening parabola having its vertex at origin and focus at a comma 0, that is 1 comma 0. Fine. So this is how both the curves involved in this question are interacting with one another. No doubt, you can check out the points at which both the curves are intersecting each other as well. Right. Now, there is one line which is a common tangent to both the curves. Let's say it is this line. See, I'm not sure if there is one line or more than one lines. In order to reach to the conclusion that how many common tangents both these curves actually have, I will have to compute the number of distinct slopes. As many as I get the different real slopes, those many are going to be the number of common tangents to both these curves. Right? Now, I'm going to consider T to be one of the common tangents to both these curves of slope M. I don't know how many in total the number of common tangents exist of both these curves. Right now, I'm only interested in this one general common tangent to both these curves of slope m, which is my line t. I am going to work intensively on my line t, and then we are going to keep commenting accordingly. Okay, so t has two specialities. It is a line of slope m, which is a tangent to my parabola y square equals 4x, and it is also a tangent to the given circle. We know as a matter of fact that the equation of a tangent of slope m to my parabola y square equals 4ax looks like what? Y equals mx plus a by m. So the equation of my tangent line will be y equals mx plus a by m, where a is 1. Okay, fine. So by using the fact that capital T is a tangent to my parabola, I have deduced its equation. But along with this same line is also a tangent to my circle, right? I know that a line is tangent to a circle if and only if, when you find out its perpendicular distance from the center, it is equal to the radius. Okay, so when I compute this distance, let's call it d, then this d is nothing but the radius, that is 3 units. All right. So first of all, let me write the equation of my tangent line in a prettier form. It will be what? My equals m square x plus 1, that is m square x minus my plus 1 equals 0. This is my tangent line. I want to compute its distance from the center 3, 0, and that will be equal to 3 units. So perpendicular distance of the point 3, 0 from this line is given by what? Mod of m square into 3 minus m into 0 plus 1 upon under root of m square whole square plus minus m whole square equal to 3. So this is representing the perpendicular distance of the line from the center, and this is my radius. Yes? Let's resolve this. What do you get? 3m square plus 1 inside the mod upon under root of m to the power 4 plus m square equal to 3. Cross multiply, you get this here. And now obviously you have to square both sides. What do you end up getting? 9m to the power 4 plus 1 plus 6m square equal to 9m to the power 4 plus 9m square. This cancels out. What you're left with, 3m square equals 1, which implies m is plus minus 1 by root 3. What are you getting? You are getting two distinct values of m. M was representing the slope of this common tangent. I initially only said I don't know how many common tangents exist, but because I'm getting two distinct values of m, which are representing two distinct slopes, hence I can say that corresponding to both these slopes, I will have two distinct common tangents to both these curves here. You got the drill? Yes, but there is a catch. I am only supposed to work on that tangent which gives me points of tangencies in the first quadrant, right? Which is the tangent that is drawn in the diagram here. And you can clearly analyze that this tangent is going to make an acute angle with the positive x-axis. Isn't it? That means I only want the tangent which is going to give me a positive slope, not a negative slope. So out of both these slopes, 1 by root 3 will be accepted, whereas minus 1 by root 3 will be rejected. Okay, corresponding to the common tangent having positive slope, I am going to get my coordinates of P and Q, which are the respective points of tangencies. Right? That means if I start computing or deliberately start writing the explicit equations of the common tangent, they are coming out to be 2 in number. Y equals mx plus 1 by m was the equation. In place of m, you plug in 1 by root 3. What you will get is this. In place of m, when you plug in minus 1 by root 3, what you will get is this. These are the explicit equations of two common tangents. But I am interested in the one with the positive slope. So I am going to accept this and reject this. Got it? So now understand the picture, okay? C comma D, that is point Q, is the point of tangency of the line T with the parabola. And what is the parabola? Y square equals 4x. And what is the equation of line T? y equals 1 by root 3x plus root 3. I know as a matter of fact that the coordinates of the point of tangencies for such a parabola happen to be what? They happen to be a by m square, comma 2a by m. A I know is 1 because I have compared 4ax with 4x. So 4a equals 4 gives me a as 1. M I know is 1 by root 3. So plug in the values of a and m in here. What you will end up getting? Let's calculate. A is 1. M square means 1 by root 3 whole square. That gives you 1 by 3. And comma 2a, that is 2, upon m, that is 1 by root 3. So basically you get 3 comma 2 root 3. Yes? 3 comma 2 root 3 are coming out to be coordinates of point Q. So on comparing, you end up getting the value of C to be 3. Fine. Now I also want the value of A. That means I have to now chase the coordinates of point P, which are the point of tangency of my tangent line to the circle. Yes, or in other words, if you just replace the spectacles that you're wearing and look at this with a fresh perspective, you will realize that when line T is intersecting with the circle, it is giving rise to a single point of intersection. That means when I am going to solve the equation of my tangent line and the equation of the circle simultaneously, what I'm going to end up getting is a quadratic equation having equal roots. So let's do that. I am going to solve the equation of circle and the equation of my tangent line together simultaneously. For that, what I'm going to do is I'm going to pick up this expression of y and put it here. Okay, I picked up the expression of y from the lines equation and plugged it in the circles equation. I got this, which is an equation involving just x. When you simplify this is very simple, basic calculation, a plus b whole square identity. When you simplify this, what you end up getting is a quadratic equation in x. Mind it, the value of x from here will represent the x coordinate of point P, which is the point of intersection of my line and the circle. Alright, so when you resolve this, what you get is 4x square minus 12x plus 9 equals 0. Use your quadratic formula. X will come out to be 12 plus minus under root 144 minus 144 upon 8. This will give you 12 by 8, which is nothing but 3 by 2. So you are getting two values of x from here, both equal to 3 by 2. Repeated roots, equal roots, I told you, right? That means the x coordinate of point P is 3 by 2. So A is 3 by 2. I don't need B, so let's not waste any time in computing B. You can compute B as well. How? You can make the coordinates of point P satisfy the equation of your line. Yes, so in place of x, when you plug in 3 by 2 and solve for y, you will get B. But I don't need that, so I am not going to do that. Small a is obtained 3 by 2. I already knew small c is 3. So now, bring in the expression in picture, twice of a plus c. In place of a, you plug in 3 by 2. In place of c, you plug in 3. What you end up getting is 3 plus 6, which is 9. Alright, so 9 is your final answer. I hope you got the drill which I adopted to solve this question, because when the question is based upon the concept of common tangent, the methodology of driving that question is pretty much same always, no matter what the two curves are. So if you have absorbed the strategy that I used in here to reach to the answer, great, you can replicate this in any question which is based upon the concept of common tangent and you will be good to go. Okay? Now let's move ahead and check out this question from indefinite integrals. It's pretty interesting and the solution itself is even more interesting. So let's check out. The integrand you can see has 3 sitting in each term. So I can extract this 3 out. I will be left with mod of x square minus x minus 2 and the limits are going from minus 2 to 2. If I individually focus on this quadratic expression x square minus x minus 2, I can break the middle term. This is x square minus 2x plus x minus 2, which is x into x minus 2 plus 1 into x minus 2, which gives you x plus 1 into x minus 2. That means this can be written as 3 times minus 2 to 2 mod of x minus 2 into mod of x plus 1 dx. The moment your integrand is written as the product of two individual linear modular terms, What is the next step? Next step is to split this integral. And what is the point of split? In order to do that, you have to catch hold of the critical points from both these mod expressions. Okay, so when you equate mod of x plus 1 with 0, what you get is x plus 1 equal to 0. That means x equals minus 1. And when you equate mod of x minus 2 with 0, you get x minus 2 equal to 0, giving you x equals 2. And the original limits are from minus 2 to 2. So if on the real line, I plot this as minus 2, this as 2, apart from that, I'm getting another point as minus 1. Bingo, I have got the point of split. From minus 2 to minus 1, I will put one integral, plus minus 1 to 2 will be the other integral. So I am going to write this as 3 times integral minus 2 to minus 1 of mod of x minus 2 into mod of x plus 1 dx plus integral of minus 1 to 2 mod of x minus 2 into mod of x plus 1 dx. Don't forget this 3, okay? Keep this intact. Alright, now what about the behavior of the mod expressions in each of these intervals? See, you know that mod of x minus 2 is same as x minus 2 when x is greater than or equal to 2, and it is minus of x minus 2 when x is strictly less than 2. When in here x is less than minus 1, it obviously is less than 2. So mod of x minus 2 will be nothing but minus of x minus 2, that is 2 minus x. And what about mod of x plus 1? I know mod of x plus 1 is same as x plus 1 when x is greater than or equal to minus 1, and minus of x plus 1 when x is strictly less than minus 1. Right now x is less than minus 1, so mod of x plus 1 will be minus of x plus 1. Yes, minus sign here, x plus 1. Minus of 2 minus x, let me write it as x minus 2. Sorted? Let's move on to the next integral. In here I have mod of x minus 2 will be, I told you, x minus 2 when x is beyond 2. And it will be minus of x minus 2 when x is lesser than 2. Right now my limits are from minus 1 to 2, so x is lesser than 2. That means mod of x minus 2 is nothing but minus of x minus 2, that is 2 minus x. Okay? And in here x is greater than minus 1, so mod of x plus 1 will be same as x plus 1. Right? Okay. We're just one step away from the final answer. This is minus 2 to minus 1. Multiply, what do you get? X square plus x minus 2x minus 2 dx plus integral minus 1 to 2. In here you get 2x plus 2 minus x square minus x dx. So this boils down to what? X square minus x minus 2, and this boils down to what? Minus x square plus x plus 2. Isn't it? Yes. So this is one integral, this is another integral, and outside you have 3 common. Now you know what to do. Well, integrate x square, it is x cubed by 3. Integrate x, it is x square by 2. Integrate 2, it is 2x. Again here, minus x cubed by 3, x square by 2, 2x. And plug in the respective limits, minus 2 to minus 1 and minus 1 to 2 here. Okay, basically plug in the limits minus 2 to minus 1 in the first expression and minus 1 to 2 in the second expression. When you will do that and resolve, it's just basic arithmetic calculation, your answer will come out to be 19. Fine. So the answer to this integral question is single digit number, or I should say 2-digit number 19. Got it? Time to check out this question. It says that if the remainder when x is divided by 4 is 3, then find out the remainder when this complete quantity is divided by 8. So 8 is the divisor which is going to come into play now. Keep this in mind, okay? So first of all, let's work upon x. X is leaving the remainder 3 when divided by 4. That means I can certainly write my dividend x as what? Divisor into quotient plus remainder, right? So whatever my quotient is, 4q plus 3. Yes, isn't it? So my x is going to look like this. The moment I have figured out the look of x, now let's move ahead and check out this complete quantity upon which we have to work. So what is the quantity? The quantity is 2020 plus x is 4q plus 3 raised to the power 2022. I want want to find out the remainder which I get when I divide this complete jumbo quantity with 8. Fine. Okay, let's first of all work upon simplifying this. See, because I'm interested in 8 to be the divisor, somehow I have to convert this inside expression as a multiple of 8. But wait a second, if I talk about 2020, when you divide by 8, what do you get? 8 into 2 gives you 16, remainder is 4, then 8 into 5 gives you 40, 20, then 8 into 2 is 16, so remainder is 4. That means 2020 is not completely divisible by 8. I'm getting the remainder 4, that means 2024 will be divisible by 8. So I'm going to create 2024 inside here. I already have 2023, isn't it? I'm going to write this as 2024 minus 1. Okay. Deliberately I've done that. So what am I now left with? 2024 plus 4q minus 1. Now if something is divisible by 8, it is also divisible by 4. And 4q is already divisible by 4. That means both these quantities individually are divisible by 4. Yes. So their sum will also be divisible by 4. So I am going to write this as 4 into something, let's call it lambda, minus 1 raised to the power 2022. Okay. Did you understand? Alright. So this is now the expression that I have to work on. I have to divide this expression by 8 and see what is the remainder. What is the drill? It's the question based on binomial theorem. So I'm just going to use my basic binomial expansion. What will it come out to be? So 4 lambda minus 1 raised to the power 2022 is nothing but 4 lambda plus minus 1 raised to the power 2022. This will be NCR, NC0, 4 lambda to the power n minus 0, that is 2022, into minus 1 raised to the power 0. Okay, minus 1 raised to the power 0 is nothing but 1 only. Plus n C1, 4 lambda to the power n minus 1, minus 1 raised to the power 1. Okay, plus and so on, 2022 C 2021, 4 lambda to the power 1, minus 1 to the power 2021, plus last term will be 2022 C 2022, 4 lambda to the power 0, minus 1 raised to the power 2022. I've just used my binomial expansion, nothing major, nothing great, nothing rocket science. Look at this last term. You know this complete quantity, NCN, is 1. Yes. 1 into 4 lambda to the power 0 is again 1, and minus 1 raised to power an even number is again 1. So this complete last quantity will be 1. Let's look at the remaining ones. 2022C0 is again 1. 1 into 4 lambda to the power 2022. This complete first quantity is certainly divisible by 8. That's what I have to check now. Okay, I will check each quantity if it is divisible by 8 or not. That is the strategy, that is the drill to tackle such questions. Yes, so I can clearly make out that my first number is divisible by 8. Second number is also divisible by 8 for sure. Third number will be divisible by 8 and so on. My second last number will also be divisible by 8. So from first digit to second last digit, my last digit is 1, okay. First digit to second last digit, each digit is divisible by 8. That means their sum will also be divisible by 8. So the sum from first digit to second last digit completely is divisible by 8. So that will be expressed as 8 into something, let's call it m, and last digit is plus 1. That's it. That means you have transformed your expression as 8m plus 1. Now 8m plus 1 you have to comment upon leaves the remainder what when divided by 8. It's but obvious. 8m plus 1 when you divide by 8 will leave the remainder 1. 1 is your final answer. So I hope you got the methodology which I used to tackle this question, because this is what is supposed to be replicated whenever you get a question on this ground. Cool?